Hello students, so today we are going to wind up this GATE 2014 paper. From this video set 3 I am going to wind up. Rest of the sets I will discuss subsequently in many videos. So let's see the 50-second question. It is from production. So a cylindrical riser is with a diameter D and H height is used. This is the mold cavity, this is the sprue basin, everything is given in the question. So okay, if the riser of constant volume uh, means let me read the question first. A cylindrical blind riser, okay, with diameter D and height H is placed on the top of the mold cavity of a closed type sand mold as shown in the figure. If the riser is of constant volume, then the rate of solidification in the riser is least when the ratio H by D is. You should be remembering this as a direct formula, although I am going to explain the derivations also, but it will be better if you remember the direct formula in case of blind riser or in case of side riser, okay, top riser or side riser. Okay, so we know that here it is given the riser volume is constant, so we know the volume of a cylinder is pi by 4 d square, so we can calculate H in terms of D. Okay, so as we know solidification time is proportional to volume by surface area whole square. Okay, so surface area means from where the heat transfer can take place, so it is the surface area means pi dh as well as pi by 4 d square, the top. From these two the heat can be ejected or heat can be lost. So these are the two surface area, so you have to find out the surface area as pi dh, okay, plus pi by 4 d square, and you can substitute h in terms of v here. Okay, so for minimum as or for minimum area, now you can different as we know the calculus. So minimum area you can differentiate it and you can equate it to 0. So from here you will get the equation v is equals to pi by 4 d square h, sorry, pi d cube by 8. Okay, and we know what is the value of v, which is pi by 4 d square. We have to take v as constant. While differentiating you should take v as constant since the volume of the riser is constant. Okay, so pi by 4 and then equate it to pi by 4 d square h, so you will get d is equals to 2h, or the ratio of h by d is 1:2. Okay, you should remember this as a direct formula always. Now let's see the next question, 53. Here two balls are inside a ring kind of structure. Okay, so ball A and ball B, or bigger ball and smaller ball. So you have to find out the diameter of the ring. Okay, two spherical balls of diameter 60 and 40 is given. Height h2 is given as 35.55. Here h1 is given as 20.55, and you have to find out the diameter of the ring gauge. It's very, what to say, it is a simple geometry question. The diameter is the radius of bigger ball plus AB plus the radius of smaller ball. So you have to find out AB. AB is AC square minus BC square. Okay, so it's very simple. AC we know R1 plus R2, and you have to find out BC. How you can find out BC? H minus H1 minus R1. Okay, so this we got complete. So you can easily derive this. AB is very simple, just a geometry. H minus H2 minus R2 or R1, this bigger radius, minus of H minus H1 minus this smaller radius. So you will get this BC very easily. Okay, so just substitute the formulas, just do the calculations, and you will easily get the answer as 93 ml. Okay, or you can take a theta also and you can do, but that is also okay, not a big deal. Okay, now let's see the question number 54. Which pair of the following statement is correct for orthogonal cutting using a single point cutting tool? Reduction in friction angle increases the cutting force. Okay, reduction in this is wrong actually. Reduction in friction angle decreases the cutting force. This is correct. You can see with the help of merchant circle diagram also. And our option is reduction in friction angle increases the chip thickness. No, this is wrong. Reduction in friction angle decreases the chip thickness. Okay, so Q and S are correct. This is a theoretical question. And last question is from spot welding or welding chapter. So for a spot welding of two steel sheets, each of 3 mm thickness, okay, the welding current of 10,000 ampere is applied for 0.2 second. Spot welding is basically a resistance welding. So the heat dissipated to the base metal is 1000 joule. Assuming that the heat required for melting 1 millimeter cube, actually this is what to say, heat density you can say, 20 joule, and the interfacial contact resistance between the sheets is 0.0002 ohm. The volume of the weld nugget. Okay, so we know heat given I square RT is equals to heat utilized for the melting the nugget. Okay, so density into volume of nugget into heat generated heat, what is this, HR by G. Okay, 1400, let me see just a second. I we know is 10,000 square, resistance we know, time we know, um, density we know, volume of nugget we have to find out, and yeah, heat dissipated to the base metal is 1000 and 1400. Just a second, let me see. Welding current 10,000, base metal is 10. Okay, so the volume of nugget comes to be this. Okay, then the simple calculation is there, nothing else is there. Just revise the welding chapter. I need to see this question. I'll see this question once again and I will explain you what is this HR. Okay, what is this 1400, I need to see. Okay, so here this is a very basic question and no need to get worried about this. Just look at the question and revise the welding chapter and you will be easily able to solve. In case you have doubts, just see the solutions, and in case you have doubts, you can go through Ghosh and Malik from manufacturing process, and it is a very basic and simple question. Okay, so all the best guys, and we'll be discussing rest of the questions in the next videos. I'm going to take previous year questions. So see you in the next video and have an awesome day.